Need to find a seat for our last breakout for the day. It's a great topic, black belt topic, debugging microservices application. I'm proud to introduce Idit Levine. She's a founder and CEO of Solo.io, hot new company in Boston. And welcome Idit.
Hey, thanks so much, guys. So thank you so much for coming. It's the last talk, 5:30. I'm from Boston, so for me it's already very late. I'm very tired. So hopefully you will find it useful. So we're going to talk today about debugging in general. We're going to touch on a lot of stuff. We're going to touch about open tracing and open consensus. We're going to talk about some debugging product. We're going to talk about service mesh. How can we not? And so on. So hopefully it will be useful. So first, just one little thing, and then we'll take it away. My company is Solo.io. We are based on Cambridge, Massachusetts. We're doing a lot of stuff in the open source. What you see here is a lot of product. Go check it out. I think it's pretty cool. So let's talk about the problem that we're trying to solve here. So debugging microservices is hard, right? I mean, let's understand why. So back on the day when we were doing monolithics, we had one big binary that consists from every logic that we needed in the application. And we could easily just attach debugger and see what's going on inside. So they weren't distributed here at all, right? It was one that I can attach and see basically all the memory, everything that's happening in the space, which was pretty confident. That's changed when we decided to move to microservices, because now everything is distributed, which means that the state of the application is really, really spreaded. And if the state is very spreaded, you're kind of like missing right now this holistic approach of kind of like, I can see everything that I'm doing. So it's way, way more complicated, and it's just, suddenly the holistic view has disappeared. In this slide, I'm showing a few microservices here, like 6? But it's actually looking like this, right? I mean, this is some example for Twitter and Netflix. This is how their architecture is looking, which is really, really complicated. So if it's 6, maybe we can somehow manage that. When it's becoming 500, it's really, really hard to debug. This is a tweet of someone that tweeted on the internet, and I really, really liked it and find it very, very hilarious. But that's really, really the situation right now, right? I mean, that's basically what we're trying to do. We have this we're very lucky of kind of like making our velocity better, because now everything is microservices. But then again, we kind of like lose a little bit of the observability. So we need to bring it back. So what we will talk right now is how can we bring it back, okay? So observability. So the first thing that we're talking about observability, there is 3 sections that I see here. The first one is logging, right? Just we need to collect the logs that we are logging in the application. The second one is metrics and monitoring. How can I make sure that, I can see metrics and see what's the state again, if there is any problem, any errors, any for that we're getting, any problem with 500 internal error and so on. And the last one is tracing. And that's interesting specifically, and in my opinion, this is the most different one when we're talking about microservices, because logging we had before, and it's all good. And monitoring, it's on the net. It's really, there's no really complexity by doing it microservices. But tracing, it's a little bit more different, because now you have those logs everywhere, and you need to kind of like match the way to kind of like consolidate them together that will make sense. And that's what tracing is trying to do. So we will talk a little bit about tracing. Again, hopefully, I will go fast, because I'm assuming that maybe you know that. But basically, this is the idea with tracing. So right now I have a lot of logging, they're each, relating to in each microservices. And what is really hard to me is kind of like do it in a transactional way, that basically saying this request is, on this request, it's moved from those microservices, and with all the replication controllers, it could be a lot, and to collect the right one with a unique ID. So that's basically what open tracing and all those conventions is trying to do. What they're basically trying to do is to basically, on the first, when you initiate the request, they're putting an ID for it. And then this ID is basically propagating down to everywhere that your application is going. And then, eventually, it's getting to this central place that's capable of taking and kind of like consolidating based on time and everything, and create what calls span. So I basically can take this model of how my application look, A call B and E, who call B call C and D, and make this from it, right? This is basically what happened in my application. I have an application, and this application, A call B, call C, and so on. So it's just giving me an ability to understand, and A and B and C and D is basically logs, right? It's logs that I'm collecting. So that's that. So open tracing itself is basically as a standard, right? It's basically an API specification for what those API that your application need to apply in order to be able to actually eventually take all of this and be able to choose whatever provider you want and switch between them if you want. So that's what open tracing came. And then a few time after it, Google announced Open Consensus, which is basically a format that's competing. It's a little bit wider because it's also doing metrics and others, but it's basically competing. And what we saw very recently is that those guys decided to play nicely together, which means that they're working on a new thing, that it's basically going to be a very basics functionality that share between those other, and what they're trying to do is basically to merge those environments, those companies, those community together. So that's basically open tracing. I think that the best way to understand what it's really doing is just showing it, so I'm going to show you some demos. Okie dokie. You don't see it. Why can't I see it? 1 second. That would be interesting. Yeah. Can you just do them? Sing it? Yeah, no, but I prefer that it will be mirror. That way I will not need to start. Much better. Awesome. Thank you so much. Okay, so I spin up the demo, and this is what it gave me. And this is a very simple application. It's actually not been done by us. It's done by the Uber guys, because what I'm showing here is Jger, which is their implementation for open tracing provider. Just to show you what these things is doing is that basically what you're getting is Jger. It's a very simple application. And what we will do right now, we will go to this write-on-demand application that I wrote, and we're just going to ask for one write. So now, let's go 1 second and see what already I got from Jger by doing this. When I go into the dependency, now you will see that I immediately got this. They basically understood what's going on in my application. They understood that I have a forend that ran to a route, that went to a driver, that went 14 times to Redis, going to customers, go to my SQL. And basically, all of this I understand from one time that I click on the application. It's pretty simple. Now, just for curiosity, if we're going right now to the log of this application, which is what you can see here, I will make it bigger, look what's happening when I did this. So all of this is logs for this application. This is where it started. Look at this. The only thing that I did is I click one time and look how much information did I got. Right? It's going on and on. So that's pretty a lot. And to make sense of it, it's not that something that it's pretty simple. Another thing that I can see is that if I'm coming back to Jger, I can go and ask for the front end and see that I already got this. So what is this? This is basically telling me what happened, right? I can totally see that I have, I can come and I can click and see the logs that are happening. I can basically that's what's called a span, that basically showing me what happened in the system, how much time it's happened, what's happening. And this is what I mentioned that we propagating the context down. We basically, the idea, we also creating what's called a budget claim that basically we can also propagate it here. So everything that you will put in this bag is going to go all the way to your application, and then we can consume that. So that's what you can see. We can see that there is some errors, so we can go and explore and see what happened. What happened here is it's timeout, right? So we have a timeout in Redis, so you probably needed to retry, and so on. So that's really, really useful. Now, the funny thing is that if you're going right now, you can see that he knows quite a lot about these errors already, just by simple logs. So now, but this is kind of like boring, right? Because we just clicked one. I think it would be way, way more interesting if we will click a lot. and ask for a lot of write. And what you can see, sorry about that. We'll go back to this. Yeah. Sorry, it's my bad. I need it first. We'll do this demo again. I'm sorry. I already fixed the problem, and now it's working. So do this. Yeah. OK, so we'll run it again real quick. Sorry, guys, live demo. It's always interesting. Tracing, that should work. I save this one. OK, we'll run that again. It will be more interesting now. We do exactly what we did before. Refresh that. And now what we're going to do is, again, ask for a lot of requests. What you can see right now is that when I'm doing this, the latency is going up. Do you see that? So let's understand what's the problem and why it's happening. So we'll go back right now again to Jger. Going to refresh that. We're going to the forehand, and you will see that we will get quite a lot of tracing. And each of them, there is, like, we can go inside and see what's going on. And you can see that there's a lot of problem here, right? I mean, it's waiting quite a lot. And what we discover is that the reason it's waited is because I introduced that specifically in my application. And what I did is I basically put a lock in the database. So basically what we're doing is while we're asking for the database, but we basically make it one thread at a time, which make it very, very slow. So we can easily fix that. And in that case, it will be as simple as just do this. But again, if you will look at the data that we're getting, we can see understand a lot of the stuff. Like for instance, we can see that we're looking here in the Redis. See there is, yeah. So we can see that they're basically we can easily fix this by doing this. I'm going to save it. And now when we run it again, you will see that this problem is going to disappear. Where's the percentage of one? And now we'll run this one again. Now you will see that this problem has disappeared. So basically, the point of this is that you can see quite a lot from open tracing just by playing with the application, clicking a little bit, collecting the data, and see what you're getting. I will continue because there's quite a lot of other stuff that I want to show you that I think is more interesting. OK. And my computer will relax. OK, cool. So we saw what tracing is doing. Let's understand what is the strong piece of the tracing that you're getting with. So the first thing that you're getting is logging, and that's something very important. In the end of the day, the only thing that tracing is doing is in charge of your logging. The second thing that it's doing is that theoretically, if you have the logging, you can go and figure out stuff about the metrics, right? You can actually graph the logs and so on and understand a little bit more about errors and alerts that happen. The third thing that is really, really important that it's giving you is all this context propagation, which is really, really cool because then you can get information that are much more, that not specifically, that you can propagate down to database and others and figure out, about the application itself. You can do a critical path analysis, and you can also get the system topology. But the thing is that there is a lot of stuff that is not giving you here, and that's where it's interesting. So what it's not is not a debugger. You're not debugging, right? This is not what you're doing. You're troubleshooting. It's totally different, right? I mean, in the end of the day, you're not attaching a debugger and in runtime start to stepping up. That's not what you're doing here. The second thing is that there's not an holistic view for real. Because if you think about it, you're going to see only what you actually log, which means that if you didn't log it, you can't see that, which means that it's not really the holistic view that you can get. The third thing is that you need to modify your code. In the end of the day, we can log a lot of stuff, but you need to actually attach a library of open tracing that actually will know how to go and populate the information, create the badges, and set it to a place. So that means that you need to modify your application. The third thing is that you can change any value on runtime, right? I mean, this is not a debugger. Again, in debugger, I can just change whatever I want on runtime. That's not what's happening in open tracing. And the last one, you can log a lot, but here's what's happening when you're logging a lot. You're creating a huge overhead on your network, which means that what's really happening is that you can't log everything. You need to create two samples. First of all, we're only going to take the header and not the body of the request. And second of all, you will sample. You can't take all the requests because then it's a huge network overhead. So that's exactly the reason we decided to create Squash. So I'm going to show you a little bit about Squash and what it is. We're going to see a demo, then we'll move to talk about other stuff. So what is Squash? So in the end of the day, when we did a monolithic application and I was developing it, what did I do? I just attach a debugger and see what happened. That would be really cool if I can do it in microservices, but microservices is more complicated. So what basically Squash is doing is orchestration of debuggers. And I will explain what it's doing, but the best way to actually explain that is just by showing it. So I will show you real quick. Okie dokie. So what we're doing right now, we'll go here, we'll run. Okay. So that's just going to spin it up on AWS in a sec. And we will talk about exactly what it's doing. So the idea with Squash is that when you're getting an application, usually what you're doing, you just basically, usually when you're getting an application and you have a problem, usually what you're doing is you either log in right now in microservices, or maybe you're going to open tracing and look for the logs. Maybe you need to wait 10 minutes because it's taking time, right? I mean, and that's really not the right way to do that. So what we did, and in a second, my demo will wake up, hopefully. And I will be able to show you that. I put them 1 minute sleep, so that's why I have to wait right now. So basically, I will talk through it until it's actually going to wake up. So basically what we did is this. We basically created an extension for IDE. And the way it's basically working is that you have, you will be able to go and basically just ask to debug a container. When you ask to debug a container, it will give you a list of all the pods that are running in your cluster that you are available to see, and you will be able to choose the one you actually wanted to debug. And then we're going to do some games to make sure that it will attach the right one, the debugger to the right container. And that's not a simple thing, and I really hope that the demos will wake up. What's happening? Stupid network. Okay, so maybe we will talk about what is Squash, because I can't show you what's going on. Okay, now it's looking good. So basically, what we're going to do is this. Basically, what we're going to do is, as I said, we will attach a debugger to a different one. I will show you first what we're going to do, and then unfortunately, hopefully the demo will work. I don't know what's going on. So go back to the presentation until these things will work. Okay, so I will show you soon what we're doing, and hopefully very soon, but before that, what I will show you is what's going on here. So basically, there is two mods to Squash. There is a secure mod and a default mod. And we will start with the default mod, and we will try to explain what's going on. So basically, this is my situation, right? I have a node, I have a namespace, I have one container, and I really wanted to debug it. The way to do this is that the way Squash is working is that it's basically in the namespace of Squash is basically creating a container with the debugger itself. And the only thing that it's doing after it is just basically attach it to the debugger. Now, sounds simple, but it's way, way more complicated. So let me explain you why. Because in the end of the day, we are running in a namespace. Here's this. Okay, because in the end of the day, what we having here is a problem with namespace. If we want to attach the debugger to the container, we need to know what is the PID that's running in the namespace of the operating system. This is a problem that we have. So if you're looking here, what's going on is this. We have a namespace of the application itself. There is a namespace of Squash. And what we're going to do is this. We need to understand, because in the operating system, namespace, basically, Docker is basically virtualized the namespace, right? So basically it's virtualized its own environment. And therefore we need to figure out what is the real PID of the container inside the system itself. The way we're doing it is we're basically creating this Squash container that's going to the CRI and running inside the container. The communication here is through Linux socket, and it's basically running this command inside the container. What this command is doing is basically trying to find what is the unique identifier that you have in your system. In that case, it's the inode. So basically what we're doing, we're basically getting the namespace of all the operating system, what is running there. We're finding the inode, which is the unique identifier for this PID in the host name, not on the container namespace name, in the host name. And then what we can do is basically we attach the container to this PID, and we bring it back all the way to the IDE. Again, I'm sorry, unfortunately, I don't know what's going on. It's like the network is not playing nicely with me today. It's all running on AWS. In the secure mode, it's the only way we want to make sure is that you will be able to debug only what you're capable of debugging. The way we're doing it there, we're basically writing a CRD. So like we're installing some Squash piece that basically watching a CRD that's happening in every namespace. CRD intent is that ID. If we're capable of writing the CRD to your namespace, it means that you can debug it, right? It means that you have permission because we're using your context. If that's happening, then we're basically doing exactly the same thing and attach the debugger. So again, what we're really doing here is piping, and I wish I can show you the demo. Maybe I will just hack and figure out what's wrong here. Okay, so that's that. We will continue because unfortunately stuff is not working very well, so I will show you something that is recorded that is going to work. So by us actually debugging in the production, in a container and that attaching container, this is all good. But in the end of the day, this is something that you cannot do in production. You cannot attach debugger in container in production because it will pose the request. So for that, we try to see what we can do. So let's kind of like looking at debugging production in general. Let's say that I have a request. When I'm requesting the request, it's going to another microservice, so maybe going to a database, or going to another microservice, going to maybe S3, and continue the request. So usually what you're doing in that case, you will try to propagate the data to open tracing or open consensus. The problem that you will have with this is that you need to modify your application. It's also very busy on the network. So maybe we can use service mesh. So in service mesh, what we're going to do is we're going to basically run a proxy next to every application that we have, and we're going to do something like that. The request will look something like this. Every time that you want to talk to your application, you have to go from this proxy that will basically going to happen this. And then the proxy, we can get the information from the proxy, so I don't need to modify the application. So first of all, I still need to modify the application. This is one of the problems that open tracing has with service mesh. You do need to modify the application because you need to put stuff in the bag. Otherwise, it's not going to be in the header, and it means that it's not going to go eventually to open tracing. So that's not something that will work for you. So when we looked at it, we said, wait, what is open tracing trying to do here? They're trying to take every log that's happening in production. Do we really care about the one that are successful? If something is successful, it's really important to us to actually send it to one location? Maybe not. So what if we will do something else? What if we're going to basically attach, record everything that happened, and because we have proxy, in that case Envoy, I can just easily use tab and record anything that's happening and any request that we're getting and any response that we're getting from the microservices. If we're actually going to record all of this, if it works and there is no error on those requests, I don't care about that. I'm just going to toss it away. But if what I see is that in this request I have a problem, what I can do there is just save all this information. So basically, I'm recording everything that is, every communication, every request and response that was on production, if in this transaction, no matter which microservices I had a problem. And then what I can do, and we're calling it loop. And then what you can do is you can basically attach Squash again. Hopefully, we will try the demo again. If it will work, it will be great. And be able to actually replay it. So we can take and actually record everything that happened to you in production and replay it in your environment. And then again, because every communication is going through this proxy, that means that also the database information is going back, which means that I can actually record that. I mean, I will show you a demo that's recorded, so that have to work. Okay, hopefully that's big enough. So we'll show you what we're doing. So basically, it's pretty simple. What we want is to basically use the network that we have, right? I mean, I'm going to go very, very quick. But basically, what we have is that what we want to do in this demo is just demonstrate that we'll be able to recording everything that's happening. We're collecting this information. And once that happens, we can actually spin up Squash to debug that. I'll show that in a second. So what you can see that we're doing right now is just basically running a very simple application in Kubernetes, the pet store, right? So it's really simple. We're running it. You can see that it's working. It's all good. The next thing that we're going to do, we're going to try to send some requests to it, right? What you will see in a second, so we just create some batch that's basically running some requests. Yes, so we're just basically going to simulate 3 requests and see what's going on. So what you can see is that the first one is successful, the second one is successful, the third one failed. So that's a problem. So what we're going to do next is basically do the same thing, but we're just basically going to do it with loop. And what you can see is that we'll be able to get immediately, so loop will immediately detect the problem of the third one. Only the third one will be saved. We didn't save not the first one and not the second one. And then when we'll do this, we'll be able immediately to attach the debugger. So the debugger, the extension itself is watching loop, and once you see that something is open, it's attaching immediately the debugger, and basically start the debugging with this value of request. So you basically do a curl with all the requests, text, body, and header, and basically running it. Another way that we can do it, and this is something that we're working with Lyft on, is that Lyft specifically has their own system in a support system inside. And when something is going wrong, they're calling and they basically say, someone says something is going wrong. What we're adding is basically a button that you can click on it, and then it's going to record only the transaction of this specific user, and then you will be able to debug it because you're basically snapshotting everything that you have in production at that time. Hopefully that makes sense. So I'm sorry about that. Nothing worked today. I have no clue why. It's usually not happening. Do you have any question? Yeah. No? Did you make a sense from what I said at all? Because I was supposed to show you, and that was much better if I will show you. Nothing? Well, I guess I just gave you some extra time. Okay, do you have any question? Yeah.
Okay, let's have some questions on the mic. We can start right here.
Okay.
Yes.
I noticed that the patterns, they all have trade-offs. The different having the proxy.
Right.
Will there be some innovation in that area so that
All of this is going to work together?
Yeah, so
that
that pattern gets not messed over.
Yeah, so it's actually an interesting question. So one of the problems that we have with loop, for instance, is to understand when something went wrong. How do you know when something went wrong, right? So, I mean, there's this basic stuff, right? You see 404, like in this demo. But the question is, what's going on when stuff is more complicated, right? I mean, there is a cascade error and so on. And for that, I think that we basically can leverage open tracing. Basically, if we see that something is wrong there, then we'll be able to record the same requests and so on. So there is a lot of things that we can do together to aggregate it back. It makes sense.
Yeah, sure. No one else has got a question.
Yeah.
Just to follow up on that, is there a way to ad hoc connect some more? I have two questions. One is, if you're adding all these other elements like these proxies, how do you know when those go down? And there's an issue with that.
Yeah.
You're adding more complexity to the system with these out-of-band management parts, right? So you have to trust that those are going to be stable and not messing with the data.
So what is proxy? Proxy is basically pretty dumb, right? I mean, it's not doing anything. It's taking the response and sending it. What you need is a control plane, and that's what's going on, right, in Istio and so on, right? So basically, there is some information that needs to be given by the control plane. I mean, we should assume that service mesh is solid in production, and then basically the only thing we're doing is nothing, right? We're just basically recording the traffic, which is pretty simple. One thing that I will say is that, again, I wish I could really squash, but basically what we just recorded a demo and put it online of basically us debugging Istio. So that's one of the things that is very useful, because we're all building this crazy control plane, but in the end of the day, it's very hard to debug them. Every product that we're doing, we're actually using Squash in order to debug it, because it's just really simple. Again, I wish I could show you that. I don't know what's happening. Yeah, thanks.
Over here.
Yeah.
So I was curious about when you're getting the data back from the production server. I would imagine that some clients are not super thrilled about the fact that their data might show up in somebody's debugging session. Am I missing something here, or is that something that you have to be?
You're not. We thought about it as well. So, I mean, basically, this is not that different than when you're putting stuff on the cloud and you don't want to put whatever credit cards and so on. There is first of all, you need to have a permission to record that, and this is something that we should work on. What you show you here is very a POC, right? But I mean, what we can do is basically when we're actually recording the data, go over it before when we're recording it and actually delete everything that is very sensitive. But in the end of the day, the people who actually, like in Lyft, for instance, the developer is the one that's going to debug the information of the user that just sent. It makes a lot of sense. So this is data that you can actually share, because the people who have ability to actually go there is people that allow to see those data, or at least some of this data. And everything that is sensitive, we can easily swap, right? I mean, just don't put it there. Just put a dummy data or something. So we can do that. But that's a problem that exists everywhere, right? I mean, every time that you're doing something like that, you need to fix this problem with being sensitive. But this is something that is running on your infrastructure. This is something that it's your customer, and you know what I mean? So hopefully you will be able to share this information.
Any more questions for Idit?
Yeah, sorry guys, it's go look.
No worries.
It's actually
how about a round of
working.
applause?
Yeah.
Thank you, Idit, so much. Love the demos.
Yeah.
Please try to fill out your surveys. They're in the app at the end of the session, down at the bottom. And I'm sure Idit will be posting some slides. They'll be available on SlideShare at the end of the conference. Yes. Thank you very much. Have a great night.